Hello, welcome to this 11th lecture session on database management systems. In this session, we discuss about data storage mechanisms for databases. We talk about disk packs and what are the various features of disk packs, and records, how records and files are organized which actually contain the data of the database, and what are the various file operations that can be performed. We also discuss about the ordered and unordered files and what are the advantages and disadvantages of those organizations. And for any database, the basic requirement is whatever data we create and store in the database, the first requirement is that need to be persistent. That means the storage of the data should be permanent. Second requirement is it should be as fast as possible. That means the data access should be fast enough so that the operations or manipulations can be performed on the data in a more efficient way. The third requirement is it should be cheaper as far as possible. Owing to these requirements, and nowadays the disk storage devices have become popular devices for storing the data of a database in a persistent way. Now we will discuss what are the characteristics of disk packs and how data can be stored on that, and what are the various features. Disk is the preferred secondary storage device for high storage capacity and then low cost. Data is stored as magnetized areas on magnetic disk surfaces. A disk pack contains several magnetic disks connected to a rotating spindle. There will be a central spindle to which the various disks can be, disk surfaces or disks will be connected. Disks are divided into concentric circles. They are called as tracks on each of the disk surface. Track capacities vary typically from 4 to 50 kilobytes or even more. That depends on the hardware. A disk pack looks like this. This is one disk, second disk, third disk, fourth, fifth, so on and so forth, depending on the requirement, and it may contain any number of disks. All these independent disks are actually mounted on central spindle. This is called as a spindle on which all these disks are mounted. Then for every disk surface we have a read-write head. This is called as a read-write head, and this is a read-write head, and these read-write heads are connected to the actuator, to which they are connected to the actuator with a armature or simply an arm. Like that, if you have 6 surfaces in your disk pack, there will be 6 number of read-write heads, and each one of them is connected to the actuator with armature. And the physical property of this disk pack is such that we cannot independently move these read-write heads on a single disk in an independent way, but all of them move forward or move backward as a single unit, like that. That is the basic feature of these disk packs. That means if you take this particular read-write head, I cannot make this alone to move to forward or backward on the disk surface. It is not possible, and if I move this particular read-write head to backward, all of them will move backward accordingly or correspondingly. That is the basic feature. Now a track is divided into smaller blocks or sectors. That means if you consider this as a disk, a pack may contain any number of disks, and let us assume that this is the spindle, central spindle to which all these disks are connected, and then each disk surface will have 2 surfaces, bottom surface and upper surface, and the surface of a disk is divided into, first it is divided into tracks. You will have concentric circles. The tracks are nothing but concentric circles on a surface of a disk. Then further, these concentric circles, which are called as tracks, are divided into blocks or sectors. The division of a track into sectors is hard coded on the disk surface and cannot be changed. And further, sometimes what happens is we should be very careful about the notion of block and sector. We know that a track is divided into sectors, and sometimes sector is divided into blocks. The block size could be 1 kilobyte, 2 kilobyte, 4 kilobytes, so on and so forth, and it is decided by the operating system. But the sector size is hard coded, and then it is specific to that particular hardware device. So that's why a track is divided into sectors, and sometimes a block size may be same as the sector size, or a sector may contain more than one block. Actually, the data of a database is stored on these blocks. The division of track into sectors is hard coded on the disk surface, and it cannot be changed. And a track is divided into blocks. The block size B is fixed for each system. Typically, block sizes range from half kilobyte, this is 512 bytes, means half a kilobyte, to 4 kilobytes. All blocks are transferred between disk and main memory for processing. And one more important feature that need to be understood is the data of a database is stored on the disk. Normally, we use this symbol representation to indicate the secondary storage. The hard disk is a storage device which is a secondary storage. The primary storage device is RAM, random access memory. But the difference between these two is in terms of speed, in terms of cost, and in terms of permanency of the data we store on these devices. The RAM, whatever you store on the RAM, it is there temporarily, that is, as long as the power is available, the data is available, and once the power is gone, all the data is wiped off. But whatever we store on the hard disk, it is permanent, persistent. And let us assume that this is the hard disk where we store the data in terms of blocks, and these blocks contain the records, and records contain fields which actually store the data of a database or relations, whatever it is. And then for the purpose of processing, we need to bring, and if I want to manipulate a record in this particular block 110 on the hard disk, then only that record cannot be brought onto the RAM. What is the unit of transfer of data between RAM, this is RAM and hard disk? It is in terms of entire blocks. That is, if let us assume that a block contains 10 records of employee type, and then if I wanted to manipulate or access the data of a record which is contained in block number 110, then I need to transfer the entire block onto the RAM, and then only I can access, my program or the application can access the data item on the RAM, and then copy the data item into the local program variable which is local to the application or the program, and manipulate it, and first it writes back onto the RAM, and then as and when required, using appropriate strategies, it will be written, the modified block of data will be written back onto the disk. So this is how it works. So that's why whenever we need some data item for manipulation purpose, we need to first figure out what is the block that contains that specific data item on the hard disk. Then we need to bring that entire block onto the RAM. So that's why the block is the unit of transfer of data between RAM and hard disk. And if you look at the database, relational database, it contains some tables. For instance, let us assume that I have employee in a database called company database. I have employee table and then department table. Now, employee table contains some records and department table contains some records. The structure of employee records is different from structure of the department records. And when actually the database management system stores these data related to relations or tables, for each relation or for each table a file is created. Let us assume that F1 is the file to store the data pertaining to employee data, and F2 is the another file where I can store the data pertaining to the department table. That's why for every table or relation, a file is allocated, and depending on the number of records a file contains or the table contains, that many number of blocks can be allocated to the file. That means today if I have, so let us assume that the in each block 100 employee records can be stored, and then if I have 200 employees in the company, presently the file which stores the data about employee relation requires only 2 blocks, and then tomorrow if I store 200 more employees information, further 2 more blocks can be allocated to this file. Like that, the file may be dynamic. That means today it may contain x number of blocks, tomorrow it may be more or less. It is like that. And similarly, for all relations, the files are allocated. Each file contains some blocks. The blocks contain records, records contain data fields. Okay. Now suppose for employee table, let us assume that as of now I require only 2 blocks. Let us assume that this is the physical disk and this is 101, this is 102, 103, 104, this is the block address, 105 and 106, 107 and then 108. If such is the situation, and when I start inserting data or creating the database for employee table, then file 1 is allocated, and initially let us assume that I need only 1 block to store the information about employees. Only 1 block is allocated. The block 1 of file 1, let us assume that 105 is the actual physical block that has been allocated to store this information. That means then if the number of employees is increasing, I have more number of employee records and 1 block is not sufficient. Now let us assume that I need one more block for the file. Let us assume that the second block for the file F1, which stores information about employee, has been allocated, and it can be at contiguous location or it can be at some other place. And first block of F1 is at 105 and then second block can be at 120, which is further from this existing first block. So it is 120. That means it is to say that the blocks of a file may be contiguously located on the hard disk or they can be at different locations, and there is sufficient information that is stored along with a file which indicates how many blocks are there in the file and what are the block addresses of each of these logical block. So this is the logical block 1 and 2, and then these are the physical block addresses where those first and second block of file F1 are existing or stored on the hard disk. This is how actually the data is stored. That means for every relation we have a file contains blocks, blocks contain records, and then whenever it is required to manipulate data contained in a record, we need to transfer the entire block onto the RAM. And who is going to take care of this? There are specific modules which are modules of database management system, which we already mentioned in our initial classes, that is buffer manager, file manager and disk space manager. These are the modules which are integral components of any database management system, which are going to take care of these things. File manager is responsible for allocating files and organizing files, and disk space manager is the module which is responsible for managing data space on the disk, and then buffer manager is the module which is responsible for transferring the required data block on the hard disk to RAM. The RAM generally we call it as a buffer. That's why the block on the disk is called as a disk block. The block on the buffer is called as a buffer block. It is a RAM. It is on the RAM, and invariably the size of the buffer block and the size of the disk block is going to be same. That cannot change, which is fixed by operating systems. We know that these are the tracks. This is a track, and one more track can be there somewhere like this, and one more track can be there somewhere like this. These are the concentric circles, and these tracks are divided into sectors. One sector may contain more than one block, or sometimes the sector size and block size could be same. And we have different kinds of sector organizations on disk. The first organization is sectors subtending a fixed angle. If you look at the first example, what is happening? This is the track 1, this is the track 2, and this is the track 3. But if you carefully observe, and the sector 1, this is a sector on track 1, this is a sector on track 2, this is a sector on track 4, track 3, and this is a sector on track 4, so on and so forth. But you take any sector on any track, on any concentric circle, they make a fixed subtending angle at the center. That is, they are subtending a fixed angle at the center of the disk. That means then what happens? The space available on a sector on track 1 is lesser than the space available on a sector on track 2, so on and so forth. If you move from center to, if you move towards the edges of the disk surface, then the space available, that is the amount of data that can be stored on a sector, is going to vary, because all the sectors which belong to different tracks, they are subtending a fixed angle at the center of the surface of the disk. This is one organization. The second organization is, that means here the density of data that can be stored on each track sector, in first case it is going to be different, and in the first organization on track 1, sector 1 can take only one block, let us assume like that, because the space available in a sector on track 2 is slightly more, we can store 2 blocks of data, so on and so forth. That is why the density of data that can be stored on the disk is varying for these different tracks. If you look at the second kind of organization of sectors maintaining a uniform record density, you see here I have, let us assume that this is the first track and this is the second track. Because the space available on the first track is less, that is why each sector is equal to 1 block size. Because the space available on the track 2 is slightly more, one sector contains 2 blocks, it is like that. Using this mechanism, using this organization, we are able to maintain the uniform recording density. It is called as the recording density, that is the density of data or amount of data that can be stored on each sector. Okay, and these are the 2 important sector organizations available. Now let us have a look at the concept called as a cylinder. Let us have a look at this disk pack. In this example, I have 3 disks, disk 1, disk 2 and disk 3. And when I have 3 disks, how many surfaces will be there? Let us assume that each disk has bottom surface and then upper surface. So 3 into 2, total I have 6 surfaces. And let us assume that on each of these surfaces I have 4 tracks, track 1, track 2, track 3 and then track 4. Of course, I have numbered these tracks starting from the edge or boundary of the disk surface. So the outermost track I am calling it as 1, so on and so forth. Now the imaginary, that is the number of tracks available on each surface is going to be same, it is fixed, it will not vary. It is not the case that the first surface will contain 5 tracks and the second surface will contain 10 tracks, that is not the case, and the number of tracks on each surface of the disk pack, it is going to be same. This is the central spindle on which all these disks are mounted. Now there is a notion called as a cylinder. What is a cylinder? Cylinder is a imaginary cylinder which is formed by collection of same numbered tracks on multiple surfaces. If you look at this, the track 1 on all the surfaces, you can imagine it as a cylinder, and then if you look at the track 2 on all the surfaces, I can imagine a cylinder which comprises of all the tracks numbering 2 on multiple surfaces of the disk pack. That is why a cylinder is nothing but imaginary collection of tracks of same radius from all recorded surfaces or all surfaces of the disk pack. So this is a cylinder. Now the block address, if I want to refer to a block, usually that is given by 3 components. First you need to refer to the cylinder number, to which cylinder that data block belongs to, then on which track the data is stored, and then on the given track what is the block number where I can get the data. So that is why put together the cylinder number, track number and block number together will form a block address. And one more important feature of hard disk is, if I want to read the data, a read write head moves to the track that contains the block to be transferred. Disk rotation moves the block under the read write head for reading or writing. A physical disk block, which is a hardware, hardware address consists of a cylinder number, a track number and the block number. Just now we have seen what is the meaning of this. Reading or writing a disk block is time consuming because of the seek time. It contains three components. The reading or writing, how much time is required to transfer data from a block to RAM, that comprises of three components. First component is called as seek time, second component is called as rotation delay or latency, or it is also called as latency, and third component is data transfer time. The third component, block transfer time, it is called as block transfer time. Okay. Now what do we mean by this? To read data, suppose I have a hard disk here and it contains some blocks like this, and here we have buffer, that is RAM. Now I understood that I need to transfer this particular block with given address onto the RAM. Now actually this is a view that is given for the user. With this we are viewing that, or we are representing the hard disk in this using this representation. In fact, it is a disk pack which contains a central spindle and then which contains various disks, and wherein they contain, each disk is going to contain two surfaces. In such case, suppose if this is the disk pack and then this is the read write head available, wherein each surface will have one read write head. Let us assume that these are the concentric circles or tracks, and my data is available on this block, on this track, on this surface of the disk pack. Then what should I do first? First I need to make sure that the read write head pertaining to that particular surface must be moved to the required track. There will be many tracks on a given surface, and the data you require may be available on some other track, and as of now initially the read write head may be at some other different track. In first place we need to move that read write head to the required track. This is called as the time required to move the read write head to the required track is called as seek time. It is called as seek time. All these things are specific to the hardware. Then after reaching the required track, it is not over. Immediately after reaching the track, I cannot start reading the data, because the given track is divided. If you look at this as the track, again track is divided into blocks. And suppose if the read write head is available here after moving the read write head to the required track, and let us assume that in fact my data begins in this block, and I need to make sure that read write head is available at this beginning of the required block. Then what should I do? After reaching the required track, I need to rotate the disk surface or the disk such that the read write head is exactly located at the beginning of the block which you require. This is called as rotation delay, or simply it is called as latency. And once you reach the beginning of the block, then onwards you start transferring the data byte by byte, whatever it is, from the block to using that IO device to the RAM. So this is called as reading of data or block transfer time. It is called as block transfer time. So first component is seek time, which says that go to the required track by moving the read write head. The second component is rotation delay or latency. It is nothing but bringing the read write head to the beginning of the required block by rotating the disk, and then next after reaching the beginning we will start reading the data from that block. Hence transferring data from hard disk to RAM involves these three components. And then if you carefully observe, the seek time is normally 3 to 7 milliseconds. I am giving these figures with respect to a specific hardware to give some rough idea about how much time each of these components can take. So the seek time takes 3 to 7 milliseconds, and the rotation delay, the time to position the read write head to the beginning of the block, which is called as latency or rotation delay, will be 3 to 4 milliseconds for a hard disk which rotates at a speed of 15,000 RPM, with a speed of 15,000 RPM. And normally the third component, which is called as the block transfer time, is always smaller than the above two components. And for the seek that latency or rotation delay, let us assume that this is the track which contains the required block and this is the center, and after seeking the required track, my read write head is located here. I need to make sure that the disk surface is rotated such that the block will be placed exactly under the read write head, and the read write head is placed exactly at the beginning of the block. So, to do this, on the best case is the read write head by chance may be by default at the beginning, by chance at the beginning of the block. Worst case, it could be exactly on the opposite side. The best case is like this: once you make the read write head to move to the required track, by chance the required block may be exactly under that read write head. That is the best case. The worst case is it may be at the other end, that is opposite end, making 180 degrees. So, in any case, at an average you require half a rotation of the disk for this seek time, rotation delay or rotation or latency, it is called as latency. We require half rotation on an average for this rotation delay or latency. We understood that the data pertaining to a relation is stored in a file. A file is a sequence of records where each record is a collection of data values or data items. Every file will have a file descriptor, or which is also called as a file header, which includes information that describes the file, such as the field names and their data types and the addresses of the file blocks on the disk. This is contained in this file header, or which is given by file descriptor. Records are stored on the disk blocks. The blocking factor, there is a notion called as blocking factor for a file, is that the number of records that can be stored in a single block, that is called as blocking factor. Suppose let us assume that the block size is 512 bytes and this block is meant for storing employee relation records. Of course, independent of the file or independent of the record, the block size is fixed. Whether you store employee records or whether you store department records, the size of the block is fixed. In this case, let us assume that it is half a kilobyte or 512 bytes. And further, let us assume that each employee record takes 100 bytes. Then how many full records or complete records I can place in a given block? It is given by the formula 512 divided by 100 and take the floor value. I can put 5.12 divided by 5.12, take the floor value, it is 5. That means I can place 5 records of employee type in a block, okay, in their entirety. That means this record organization is called as unspanned record organization, meaning that a single record will not spread across more than one block. And suppose in this case I have 512 bytes in a block, and then each of the record is occupying 100 bytes. First record, second record, third, fourth, fifth. After inserting 5 records, I have consumed 500 bytes, and still there are 12 bytes left in this block. And since the organization, the record organization is unspanned record organization, I cannot immediately start the next record in the remaining portion. Rather, I will start putting that new record in a fresh block. It is called as unspanned record organization. In spanned record organization, what happens is I will immediately start inserting the 6th record. That is, a record takes 100 bytes. So first 12 bytes of the 6th record is available in this, and then remaining 88 bytes of the record 6 are available in the next block. This is called as spanned record organization. That means a given record is spread across more than one block. We have two kinds of record organizations available. That is, the number of records that can be placed, that can be accommodated in a disk block is called as blocking factor for that file. Here in this case, the blocking factor is 5. A file can have fixed length records or variable length records. It is also possible. File records can be unspanned or spanned. Unspanned, no record can span 2 blocks, and in spanned, a record can be stored in more than 1 block. The physical disk blocks that are allocated to hold the records of a file can be contiguous or linked. That is what I have described in the previous discussion. That means block 1 of file 1 and block 2 of file 2, actually on the physical disk, block 1 can be here, this can be stored here, and block 2 can be stored somewhere else, and then from here to here you have a link which makes the access or navigation from one block to another block easy. In a file of fixed length records, all records have the same format. Usually in such cases unspanned blocking is used, unspanned record organization is useful. Files of variable length records, it requires additional information to be stored in each record such that the separator character and field types. If it is a fixed length record, suppose if I assume that the employee relation which is of fixed length, employee ID 10 bytes, employee name 20 bytes, age 10 bytes, so on and so forth, then if this is the case, each employee record in this case occupies 40 bytes, and then I know what is the boundary of each field. After if I look at a record, first 10 bytes is allocated for employee ID, next 20 bytes is allocated for employee name, and because each field has a fixed, all the records have fixed length of fields which are called as fixed length records, I know what is the boundary of each field in each record. Okay, I know that if I want to take the second column value or the second field value for a record, then I go to the beginning of the record and then go to the offset 10. From there 20 bytes you will get the value of the second field for that particular record. But in variable length records, the field lengths may be varying. In that case, I need to store additional information. That means after storing 10 bytes, I need to have a field separator or some separator character which marks the end of the field value, and then it indicates the next field value is starting. At the end of the second field value, again I need to have a separator, and this is the record 1 R1 of a varying length record structure. And then if you look at some other record, in this case, because the field lengths are varying, the first field in this case it could be 10 bytes, here it could be 15 bytes. That is why here I need to have a field separator which indicates the end of that field value for the record 2. This is called as variable length records. Then what are the typical file operations? We can open a file for reading, we may search to find a record with a given value. After finding a record, we may search for finding a next record for that given value. Then we may read the required record from the disk, we may insert a new record, or we may delete a given record, we may update or modify some field values for a given record, or we can close a open file and we can reorganize. That means when you keep on deleting some records from the file, it leaves some holes. At some point of time, to make the memory management more and more effective, we need to reorganize the file. That is why it is called as reorganization. We can order, we can ask the system to reorganize the file, or we can read the records of a given file in a specific order for a given field. It is also possible. These are the various operations that can be performed on a file. We have unordered files and then ordered files. First we will see what is an unordered file. There is no order. That means the records of a file are not organized on the basis of anything. So that is why it is called as an unordered file. They are also called as heap files or pile files. Whenever a new record comes, without looking at the appropriate location, I will just append that record to the end of the file. And while searching for a given record, it is very difficult because it is unordered file. While searching a record with a given value, I need to perform the sequential search. We need to search the records one by one for the required record. That is why the record insertion is quite efficient. Why? Because I do not have to look for the appropriate place to insert that record. Rather, I will be just adding the record at the end of the file. But reading the records in order to particular field requires sorting of the file. That means if it is an unordered file, if I want to get a required record with a given field value, then I need to perform a sequential search. That is why to make that search more efficient, we need to sort the records. We need to sort the records and then perform search. So these are the characteristics of a unordered file. Insertion is very simple and efficient, and searching for a file is difficult because there is no order, there is no sequence. Then we have ordered files, also called a sequential file. File records are kept stored by the values of an ordering field, and we choose one of the fields of the records as a ordering field, and then we carefully organize or arrange the records based on the value in particular order, that is ascending order or descending order. Insertion is expensive because when you insert a record, suppose I have records of files like this, record with employee ID 10, record with 24, then 35, they are in a particular order, it is a ordered file. Now if I am inserting a record with the employee ID 16, it cannot go to the end, actually it should come between this and this. That is why inserting a record is expensive. We need to first identify or locate the appropriate place where the new record can be inserted, and we need to make some space there and then insert the record. Then searching becomes very easy because they are already in a particular order, sorted order. We can apply the binary search. If you have n number of blocks, average, at an average I require log n to the base 2 number of block access to search for a record. Okay. And if it is a unordered file, if you are looking for a given record, if you have n number of blocks, then you require to access n number of block access are required. This is the difference between ordered file and then unordered file. In ordered file, insertion is difficult, finding a given record, searching for a record is very easy, effective, and in unordered files insertion is easy and finding a record is very difficult. This is an example of an ordered file. If you look at this, let us assume that there is an employee table or relation, and F1 is the file which has been allocated to store employee records. You see here, we already told that for every relation or table in the relational database, the system allocates a file to store the records of that particular relation. And here let us assume that F1 is the file that has been allocated, and now it is block 1, block 2, block 3, block 4, so on and so forth. That is, the file contains the required number of blocks, and blocks actually contain records. Here what is the, in this example, what is the blocking factor? BFR for data file is the number of data records that can be stored or accommodated in a block. In this case, it is a fixed length records, and the number of records available in each block is going to be 4. That is not going to change. So for this example, the BFR is equals to 4. I have stored, I can accommodate 4 records of employee type in each block. And files contain blocks, blocks contain records, records contain field values, and as and when it is required to modify or manipulate a record or extract a record, first we need to figure out which is the block that contains the given record. Then we need to transfer the entire block onto the RAM, and our application programs can manipulate or extract the data only from the blocks that are available on the RAM, and this is taken care by the buffer manager, and the disk block size and the buffer block size are going to be same. To understand the characteristic features of a disk pack, let us have a look at, to understand the characteristic features of a disk pack, let us have a look at this example. Let us assume that I have a disk pack which contains 3 disks. This is the number of disks, and invariably each disk contains 2 surfaces. Now what is the total number of surfaces? 3 into 2, that is 6. And number of tracks on each surface, let us assume that these concentric circles on each surface, it is going to be 10. Now number of blocks on each track, that is each track is divided into 100 blocks. Assume block size is equals to 1 kilobyte. Now what is the capacity of the track? Since each track contains 100 blocks, the block size is 1 kilobyte, it is going to be 100 kilobytes. That is the capacity of each track. Now, how many cylinders are there? Cylinders is nothing but, a cylinder is nothing but imaginary collection of same numbered tracks on all the surfaces of the disk pack. That is why the number of cylinders in the disk pack must be same as the number of tracks available on each surface. We also understood that the number of tracks on different surfaces, it is going to be same, it will not vary. Since each track contains, each surface contains 10 tracks, I can imagine 10 different cylinders. So, that is going to be the number of cylinders for the disk pack. Now, number of tracks in each cylinder is equals to number of surfaces, and then if you look at this first cylinder track here, let us assume that this track number is equals to 6, each surface is 10, okay, the track number is equals to 10. That is why the track number 10 on disk surface 1, the track number 10 on disk surface 2, so on and so forth. So, that is why how many surfaces I have in this disk pack? I have 6 surfaces. So, that is why number of tracks for each cylinder, it is nothing but 6. What is the capacity of a cylinder? Number of tracks for each cylinder and then each track capacity. Number of tracks is equals to 6, and then track capacity is equals to, which is already computed, which is equal to 100 kilobytes. So, it is going to be 600 kb is the capacity of each cylinder. Now, what is the capacity of the disk surface? Now, if you look at each disk surface, you have tracks and then each track is divided into blocks. So, capacity of each disk surface is number of tracks into number of blocks into block size, which is nothing but you have 10 tracks, you have 100 blocks on each track, and that is why it is going to be 1000 kilobytes. That is the capacity of each disk surface. Like that, you have 6 disk surfaces. What is the capacity of the disk? I can compute that in terms of disk surfaces, or I can compute that in terms of the cylinders. How many number of cylinders the disk pack contains, and what is the capacity of each cylinder? The cylinders it contains is 10, and the capacity of each cylinder is going to be 600 kb. And then if you calculate the capacity of the disk in terms of tracks, so surfaces, how many surfaces? 6 surfaces. What is the capacity of each surface? 1000. So, 6000 kb is the capacity of the disk pack. Similarly, using this formula, wherein I am using the capacity of the cylinder and then number of cylinders, that also evaluates to, that also gives us 6000 kilobytes. This is how we understand the structure and features and concepts of a disk storage. In this session, we discussed what is a disk storage, what is its importance. We store our data related to database on secondary storage, and the popular secondary storage device that is chosen to store our data is disk. Of course, we can store it on tapes, so on and so forth, okay, but the popular way of storing data is storing it on disk. The reasons are, it is permanent, that persistent, the cost is cheaper, at the same time it also effective and then efficient than other secondary storage devices in terms of speed. We have seen what are the various disk characteristics, and how to access data, what are the time components that are involved in transferring a block from disk to RAM, seek time, rotation delay or latency, and block transfer time. And we have seen the file organizations and record organizations. We have also seen what are the operations that can be performed on files, and we discussed about ordered files and unordered files. What are the advantages and disadvantages of these file organizations? Let us stop here. Thank you very much.